Okay. So, more Stoich practice. Just to continue from last week, or the last lecture, depending on when you're watching this, we're going to keep on practicing Stoich. So, how much mass will 5 grams of iron have after it rusts completely? In fact, just interesting historical note, this is one of the first things that, one of the things that led from, the transition from alchemy to chemistry is because they thought that iron lost mass when it rusted. Because, obviously it goes from this strong, powerful metal to this weak, crumbly crap. So when they finally, sat down and actually looked at it, they saw that it gained mass. They were kind of surprised. And now we know it's because it's gaining oxygen. So I'm going to go ahead and work through this now. Boom. Okay, first things first. That's not going to work. You're not going to be able to see the whole thing. So I'm going to have to do it this way. All right. We balance the equation. Iron plus oxygen yields iron 3 oxide. So if you want to practice balancing your reactions, go ahead, pause, and then come back. Welcome back. We have to double this. We need 3 of these and 4 of these. Okay, so 5 grams of iron. 4 sig figs. All right. First, we have to convert to moles. So 55.845 grams of iron per mole of iron. And then we convert to rust. So 2 moles of rust for every 4 moles of iron. And then we convert back to mass, and that is 159.629 grams per mole. Okay. All right, so now we bring up our handy-dandy calculator, and we see 5 divided by 55.845. Okay, that gives us 0.089 moles of iron. Then we divide by 2, because 2 over 4, you're just dividing by 2. So only 0.0447667, blah, 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 moles of iron, of rust, I should say, Fe2O3. And then we convert to mass, times 159.629. Means that 5 grams of iron, when it rusts, will have a mass of 7.146 grams. Okay. It will have gained a little bit more than 2.14 grams of mass from the addition of iron, or the addition of oxygen. All right, next up. Acid rain. How much sulfur does it take to make 12.5 grams of sulfuric acid? Acid rain is actually because of trace amounts of sulfur in coal. So it's a little bit more complex than this, but sulfur, you burn the coal, the sulfur will react with oxygen to make sulfur trioxide. And then the sulfur trioxide will combine with water to make sulfuric acid, and that's what causes acid rain. So once again, we bring back up the camera. We're going to have to balance these reactions. There's going to be 2 reactions. That's not a problem. You can still do stoichiometry. So, sulfur plus oxygen yields sulfur trioxide. And yes, sulfur does come S8. It comes in an 8-membered ring. It's pretty interesting. Does some pretty cool stuff when you heat it up. All right. So, again, pause if you want to practice balancing your reactions, and welcome back. So we're going to need 8 of these to balance the sulfur. 8 times 3 is 24, so that gives us 12 oxygens. Now, the next reaction is actually a heck of a lot easier to balance. H2O plus SO3 yields H2SO4. And I say it's easier to balance because it's already balanced. 4 oxygens, 4 oxygens. 2 hydrogen, 1 sulfur, 1 sulfur. So it's already done. All right. So we're starting from 12.5 grams of sulfuric acid. Okay. So how much sulfur do we need to make that 12.5 grams? Well, the first thing we're going to do is we're going to convert to sulfur trioxide. And then, beep, beep, and then we can get back to S8. Okay. So it's not nearly as bad as you might think. Okay. So it's going to be the exact same sort of thing, okay? Even though it is technically, even though it's two reactions, that's not a problem at all. So 12.500 grams of H2SO4 times, I don't know the molar mass of sulfuric acid off the top of my head. I know it's almost 100, but 1.008 times 2. Actually, no, I'm going to go, 1.0079 times 2 plus, let's see, bring up the periodic table. Come on, table.com. There we go. 32.06. There we go. And now we need this again. Slow, okay. 32.06 plus 15.999 times 4. 98.072. 98.072 grams per mole. Okay. So now we have moles of sulfuric acid. We convert to moles of SO3. That's just 1 to 1. 1 mole of SO3 for every 1 mole of H2SO4. And then we can convert directly from there to moles of sulfur. Times 1 mole of sulfur for every 8 moles of SO3. But again, well, I didn't make it explicit in the way I wrote it, but I'm asking for mass. I'm always asking for mass because I want to make you practice this stuff here. So we also need the molar mass of sulfur, which is just 32.06 times 8. 256.48 grams of sulfur per mole of sulfur. All right. So now we can plug all that into the calculator. 12.5. Oops. Really? That seems strange. So let's try that again. 12.5 divided by 98.072 divided by 8 times 256.48. Yeah, wow, okay. So the answer is 4.082863 grams of sulfur. All right. So these things get pretty formulaic after a while. Next up, driving range. All right. How many grams of carbon dioxide are produced by combusting 1 gram of octane? Well, we already balanced this in class, but you know, it can't hurt to keep practicing. All right. So okay. So 1 gram of octane, how many grams of carbon dioxide? So 1.000 grams of, I'm just going to call it octane. No, we need the molar mass of our octane, but it's going to be grams of octane, mole of octane. Back to the calculator. 12.011 times 8 plus 1.0079 times 18. 114.230 grams per mole. All right, and then we convert to moles of CO2, so that's 16, that's a terrible 6, moles of CO2 for every 2 moles of octane. And now back to grams, 44 point, I think it's 009. Yes. 009 grams of CO2 per mole of CO2. So 1 divided by 114.230 times 8 times 44.009. And that is 3.0821 grams of carbon dioxide. For every 1 gram of octane you burn, you produce a little more than 3 grams of carbon dioxide. All right, so that is our Stoich practice. Managed to get through 3 problems in about 12 minutes. Not too shabby. All right, I'm going to go ahead and shut this video down, and I will bring it back up for the next video in about 5 minutes. So I will see you later.